So here is our Lab-8 notebook on unsupervised learning. It has 3 sections. So on principal component analysis is more theoretical and with particular depths to go into PCA. And clustering is very brief with more references to scikit-learn instead. And for autoencoder, it is similar to our previous lab to build a neural network and use it for reconstruction of images. And again, I have to acknowledge the several sources that is very helpful in preparing this notebook. And there are 5 questions set in this notebook. So here we look at PCA from a latent factor analysis point of view. This is actually how PCA was proposed or invented. It is basically proposed in the context of factor analysis rather than dimensionality reduction. Dimensionality reduction is a later application of PCA. Here we also introduce a Gaussian modeling of the factor analysis model that can lead to the PCA that we have learned. Right, so here is a discussion of the PCA in the context of a factor analysis. Right, so and then our solution using eigen decomposition covered in the lecture. There's a very good example of face recognition in scikit-learn that you should go through. Right? You should go through that example in scikit-learn on face recognition. Right? So, and here is some more advanced discussion on PCA for very high dimensional data. Right? So in which case we have some trick so that we don't have to do an eigen decomposition of a very high dimensional, very large matrix. And in terms of clustering, it's very brief. Just talk about k-means briefly. And I refer you to the examples in scikit-learn on k-means and also on spectral clustering. And it has scikit-learn has a very nice comparison of many different clustering algorithms, including on the 2-circle problem discussed in the lecture that you can try out. And the last part is about the autoencoder. And again, we use PyTorch. And we work on the MNIST digit data set. And we take a subset so that we can have the result more quickly. And here is the architecture of the autoencoder. Right? So that's the convolutional layer plus ReLU and the transposed convolutional layer. Right? So similar as what you've seen in the lecture. And this is the convolutional transposed convolutional layer with no stride, right? With no stride, and this is basically we can print out, right? You can print our neural network to see the architecture, right? So this is how you can just use print for your neural network. You can see its architecture, right? And like this is how it is built, right? So that is a very useful function to use, right? So, and this is Euro stuff to inspect the parameter. That is a training process, right? I just print the loss for every 2 epoch. And then we inspect some of the reconstruction, right? So these are the reconstructed images over 1 epoch and 10 epochs and 19 epochs, right? You can see the reconstruction is improving over the epochs, right? So, and finally, that's a very interesting program to generate a synthesized image, right? So here I choose to interpolate between 6 and 5, right? So this is the interpolation in the subspace, right? So there are some questions over there. Okay, so that's all for the lab. And this finish our unsupervised learning. And in the next week, we will discuss some more advanced models, deep learning neural network models. Okay, bye-bye. See you next time.